Welcome to this video on the topic of linear equations. In this video, I'm going to show you a few strategies of how you can go about solving worded math problems. Now jumping over, we have 4 questions that I'm going to show you how we can go about solving these. In the first question here, we have when a number is trebled and then decreased by 5, the answer is 19. Find the number. So what we need to do for this particular question here is, firstly, we have to try and understand what is the question asking of us, and then we have to build a mathematical model, and finally, we have to solve the mathematical model for the unknown variable that we put in there. So let's have a closer look. We have when a number is trebled and then decreased by 5, the answer is 19. Find the number. So first thing is we're looking for a number. So we're going to write let x be an unknown number. Now next step is we have to figure out what are we doing to x. And it says when a number or when x is trebled and then decreased by 5, the answer is 19. So the first thing that's going to happen is we're going to treble the number. Treble meaning triple. And then, after that, we're going to decrease it by 5, or we're going to take 5 from it. So notice how I'm underlining. The shorter line that's closer to the word denotes the first operation associated with our unknown variable x. And the longer line underneath, that's closely or that's less associated with the unknown. So first we're going to treble it, then we're going to take 5 from it. And then finally it tells us that the answer to this is going to be 19. So what you've seen me do here is I've decomposed the problem into a set of steps. So what we can do now is we can start constructing a mathematical model, or a better way to explain it is we're building an equation. So the number that we talk about, we've associated the variable x here. So I can say x. And the first thing we do to x is we treble it. In other words, we multiply it by 3. And then after it's multiplied by 3, we subtract 5 from it. So when a number is trebled, so 3x, and then decreased by 5, 3x minus 5, the answer is 19. So answer translates into equals 19. So what we've got here is our mathematical model. Now that we've got the mathematical model, we have to find the number or solve for x. So when we're solving this particular linear equation here, first thing we need, or what we want to do, is we want to move our constants to the right and have our variables on the left. So moving the constants over, we're going to add 5 to both sides of the equation. And this will give us 24 on the right and 3x on the left. Then we're going to remove the coefficient in front of the x. So we'll divide by 3. And therefore that's going to yield x is equal to 24 over 3, and that's going to give us, so this is the first solution to our first problem, and this is the process I would go through personally if I were trying to solve this particular equation. Let's move on to a slightly different question. We have 3 consecutive integers add to 108. Find the smallest of them. So first thing we need to do here is we need to understand the language that's been used in the question. Now consecutive means one after another. So if we were counting upwards, we'd go 0, 1, 2, 3, 4, and so on. So one after the other. We don't skip anything. Then it says consecutive integers. So an integer is a whole number, and it can be both positive or negative. And those are the 2 words that could possibly throw us off in this particular question. So consecutive and integer. Now let's have another read. 3 consecutive integers add to 108. Find the smallest of them. So I've got the smallest. So what we want to do is we want to define an unknown being the smallest of 3 consecutive integers. So we'll say let x be the smallest of 3 consecutive integers, like so. Now it's time to try and construct a mathematical model. So what we need to do is we need to read the question again to try and get a better understanding of what is going on here. What is the story trying to tell? So it says 3 consecutive integers add to 108. Find the smallest. So 3 consecutive integers add to 108. So we're going to go, let's go x plus something plus something. Now x is the smallest of the 3. So we go x plus something plus something. So this is our smallest. And if that's our smallest, then this will be our middle. And finally, this one on the end will be our largest. And when we add all of these integers together, it's going to sum to give a value of 108. Alright, now we need to figure out how do we rewrite these question marks here? How can we make it such that it's a mathematical statement? And the key giveaway here is when it says consecutive. So when we go consecutive, we go one after another. So 0, 1, 2, 3, 4. So if you think about it, if x represents the number, say, if x equals 1, then the next number on from that would be 2. And the way we could represent that is x plus 1. And the next number on from 2 is 3. So we can say x plus 3, 2. And if we wanted to go one more, 1 up from 3 is 4. And that would be rewritten as x plus 3. So all we need to do is keep adding 1 to x to be able to explain the model that we're trying to build. So we'd go x plus 1 and x plus 2. Alright, now what we've got here is a mathematical model that explains this English model up here. What we want to do is we want to solve for x, and that will yield the smallest of the 3 unknowns. So solving the equation, what we need to do is we need to break open these brackets. So we'll go x plus 1 plus x plus 2, and that's still all equal to 108. Next step is we need to collect like terms on the left hand side. So x plus x plus x is 3x plus 3, still 108. And then we need to move our constant to the right. So take 3 from both sides. That will yield 3x, and then that will be 105. And then finally, to solve for x, we divide both sides by 3. And thus we're going to be left with x is equal to 35. So we say therefore x is 35. So this has been another example of how we can deconstruct a written problem. So we look at the language, and if there's anything we don't understand, we look it up so we do understand it. Then we start, firstly we think, what are we trying to find? And we write a little statement that defines the variable that we're looking for, and then we try to build our mathematical model based on what we can see here. Comparing the top one here to the second one, in the top one, the question itself was wrapped in different layers, so we had to unravel to build the mathematical model. In our second example here, the complexity came from the larger words, not the wrapping of the words in the sentence. Alright, let's have a look at a trickier one. much trickier one in fact. That shouldn't take too many lines of math to solve. So I've got Diane used a $50 note to pay for a tour of the Perth Mint. The amount of change she received was $20 more than the cost of the tour. Find the cost of the tour. So find the cost. So the way in which we can solve this is we can say let X be the cost of the tour. Alright, now let's try and deconstruct the problem. Diane used a $50 note to pay for a tour. So $50 note to pay for a tour. The amount of change she received was $20 more than the cost of tour. The amount of change received was $20 more than cost. Find the cost of the tour. So if we just read the red part, that's a useful part. So $50 note to pay for the tour, and the change received was $20 more than the cost. So what we're going to do here is we're going to build a mathematical statement. Now usually I'd start off writing it in X, but I think in this case it's a little bit easier to still keep it in somewhere between math and English. So let's think about it. The key statement we have here is the change received was $20 more than the cost. And if we say the cost is the thing we're trying to find, then we can write change is equal to cost plus 20. Because change received was $20 more than the cost. So cost plus 20 equals change. Now, let's have a think about it. How else could we describe the change given? And one way to look at it is if you pay with a $50 note, then the change you get back will be $50 take the cost of the tour. So what we're going to write is the change was $50 take the cost. And that's still equal to the cost plus $20. Now, converting this directly into a mathematical model, we can go 50 take X. There's X here. Equals X plus 20. We'll drop the dollar sign for now. Alright, so what we've got here is a mathematical model. Our next step is we need to solve it. So what we're going to do is we're going to move all of our constants on the right hand side and all our variable terms on the left hand side. So firstly, let's move the variables to where they need to be. So the variable on the right here, X, that's going to the left, so we'll take it from both sides. That will yield 20 on the right, and then 50 minus X on the left. Next one is we want to get rid of this 50 here, so we deport it by taking 50 from both sides. And therefore we're left with minus X, 20 minus 50. Collecting like terms, we get minus 2x, and then it's a messy x, minus 30. And then we solve by dividing both sides by minus 2, so we're going to get positive 15. So what we find is that the cost of the tour was $15. Reason I'm writing a sentence like this is because if we're asked a question in English, we use the math to solve the problem, but we should always report back the answer in English as well, because we're asked the question in English. Math serves no purpose by itself. We only use it to help us in real life, so that's why it goes back like this. Alright, final question. the most bamboozling of them all. We have Tony bought some small pizzas for his birthday party. He cut 4 of them in halves and the rest into thirds. There were now 18 more pieces of pizza than he had originally. How many pizzas did Tony buy? So the question is, how many pizzas did Tony buy? So let's go, let X be the number of pizzas. Now let's have a look at how we can break this down. Tony bought some small pizzas for his birthday party. So this sentence here, it's superfluous. It serves no help in the problem itself. He cut 4 of them in halves and the rest into thirds. There were now 18 more pizzas or pieces of pizza than he originally had. So constructing this, we have deconstructing, I should say. We have this first part here. He cut 4 of them in halves and the rest into thirds. Then there were now 18 more pieces of pizza than he had originally. So the way in which we can analyze this question is we want to write a mathematical model that compares the pieces of pizza. So construct a mathematical model that describes the amount of pieces of pizza. So in teal here, we've got a sentence that will help us construct an expression that explains how many pieces of pizza we have after chopping the pizzas up. So first part is he cut 4 of them into halves. So what we can say is that if we want to explain the amounts of pizza or the pieces of pizza, we can say 4 times 2. So 4 of them got cut into halves. Then the rest got cut into thirds. Now if X over here is the number of pizza ordered, we cut X, take something into thirds. Now if we've cut 4 of them over here into halves, then we're going to cut X minus 4 into thirds. So this little equation or this expression here explains how many pieces of pizza we've just chopped all of the pizzas into. Now, looking at this purple statement, we have there were now 18 more pieces of pizza than he had originally. So when you think about it, the pizzas came, they were all uncut. And what Tony's got done is he's gone and cut them himself. So the amount of pizzas when they first arrived, there were X amount of pieces because they were uncut. So it's 1 pizza, 1 piece. And then the statement says there were now 18 more pieces of pizza than he had originally. So to make these two sides of the equation equal to one another, the amount of pieces we have now must equal X plus 18. Now solving this, we are going to expand the brackets. So we'll get 8 plus X minus, not X minus 4, we're going to get 3 and minus 4 like that. So we've got to expand inwards. So we're going to get 3x minus 12. That's equal to x plus 18. Now solving, the variables have to go on the left. So we're going to get 2x. Then we're going to get 18 plus 12 minus 8. Collecting like terms, we're going to get 30 minus 8, which will be 22. And then solving for x, we're going to get x is equal to 11. So therefore, there were 11 pizzas ordered. So this would be the solution to our problem here. So going back, the way in which I analyzed this particular problem was, firstly, I removed all the superfluous junk from the question itself. So Tony bought some small pizzas for his birthday party. You don't need that because it doesn't actually tell us anything that will help us model the particular problem at hand. So just scrub it out. Then the second sentence, he cut 4 of them in halves and the rest into thirds. So I look at this and I think, what is this trying to tell me? And in this case, it's trying to tell me how many pieces of pizza he has. Then the purple one says there were now 18 more pieces of pizza than he had originally. So again, this sentence here, this third sentence, tells us how many pieces of pizza he has compared to what he had originally. Then finally, it's telling us what the question wants. So how many pizzas did Tony buy? Deconstructing it, I just say, let X be the number of pizza ordered. And then finally, we build a model that describes the amount of, or the pieces of pizza that we have, because that's the information that we're presented with in the question. So it's telling us to construct a model explaining how many pieces of pizza there are. On the left-hand side, I describe mathematically how many pizzas or how many pieces he has after chopping them all up. And then on the right-hand side, we have a mathematical statement that describes how many pieces of pizza he has compared to after chopping them. So let's color that purple there, and we'll color this one teal. So that's how these two parts of the question link up. This is the English or the written expression. This is the mathematical model. So this is the English, this is the mathematical model. Finally, we get down to 11 pizzas ordered.